Hey everyone, this is your weekly episode of the Zephyr Podcast. I'm Benjamin, your host.
And I'm Fabio, your co-host.
Yeah, I'm the co-host, I guess. I should have said that. How are you doing, Fabio?
Yeah, good, pretty good. I managed to wrap my min-max Chronicle pull request that we talked about a couple of episodes ago. So the one that I was talking about quite predictably got canned. I trashed 3 days of work and restarted from scratch with a implementation, which is not what I was originally meaning to do, but yeah, it's there. So now you can have min, max, min tree, max tree that are safe, and yeah, please use them in your code because they work better than the current one.
Oh, nice. Yeah, and as always, links in the show notes for folks. Is this the time where we do our weekly keyboard moment? It feels like for the past few weeks, we've always had one way or the other reasons to talk about all things keyboards. My girlfriend actually spotted something really cool on TikTok. I had no idea until this year, I guess, but apparently Google Japan, the folks there, I guess in the product team or whatever, they every year they build a cool keyboard and like this
some keyboard shape, some functionally equivalent to a keyboard device, I would say.
Yes. And so this one, like the one they did this year, is like shaped or like designed and modeled after those. I mean, some people listening to us might have never used those kind of phones, but
I was
like those
thinking the same.
rotary dials for like, I mean, old-ish phones. I've used them when I was really young, but I guess they died in the mid 90s or early 90s even.
Yeah, we're showing our age, Benjamin.
Yeah,
because I used to have one in my home as well.
Yeah, but actually, as a kid, it was fun to use, right? Because that's an interesting design. And so whatever they built or published, at least everything's on GitHub, all the like the STL files to 3D print and the firmware, etc., of a keyboard that you can. This is all rotary dials for all the keys.
It's multiple rotary dials. You have to see the video. I think this is brilliant. The best thing, I'm gonna spoil it, but I think the funniest thing is that there is a single element for the return button, and that is also a spinny thing. So I have to rotate it, get it to the stop, and let it go back. And it's all controlled by an RP2040 and some of those cheaper 5-wire stepper motor. It's absolutely brilliant. The finish, the quality and finish is fantastic, and it does not run Zephyr, but maybe it should.
I mean, yeah, the firmware is on GitHub. There's as I think both of us mentioned, it's a Raspberry Pi Pico based, so adapting it to Zephyr is probably. So you still haven't convinced me to buy a 3D printer, but I might convince you to. I might convince you to print the parts for me, and then I will build one. But
no, I think you need to buy a printer yourself. I'm sorry.
They're
cheap. They're cheap.
That's true. And I was looking it up. There's like apparently again they've been doing this for the last many years. In 2022, there was one that was like again kind of like an orthodox keyboard design where all the 105 plus keys were all in a single row. So it's like a 1.65 meter long keyboard wand. Like that's really cool.
Yeah, it doesn't play well with a local joke that we have that the tables in the office are getting smaller every time they shuffle people around so that they can use better the space. But yeah, this is really cool. I'm gonna have to get in touch with these guys because I think that there are some opportunities for development. Maybe doing some wireless version for the next one, something like that.
I mean, and yeah, I really wish they would have used ZMK or something, but again, everything is open. We can, someone might just end up port it to Zephyr. So that would be cool.
It's interesting to see that it was obviously RP2040 base. I mean, it's very common for hobby projects. I'm happily surprised on how well it picked up on the market.
Yep. So what else happened this week?
Talking about hobby/maker product, there's been a bit of an event the last few days, which was quite unexpected, and it involves our friendly friend at Arduino. And Benjamin, you've been on a stage apparently with all those guys, Massimo Banzi and everyone else. What do you know about it?
It was pretty awesome to see the news, and I got to be involved a bit. If you missed the news, Qualcomm acquired Arduino, because people might not realize, but Arduino is those like really nice boards that many of us have been using for the past 20 plus years. But there's actually a pretty like large company behind that. Like they just don't magically show up on Mauser and so on. Like it's like they have quite a nice portfolio of many cool boards, and like they even have like a whole ecosystem of devices geared towards pro makers and so on. So they've been doing some really cool stuff over the past many years. They've been working on some nice Zephyr stuff as well, which we will be talking about as well. And I guess, Qualcomm. So some interest in that. Just like a few months back, they acquired Edge Impulse for all things Edge AI. I guess adding more hardware to the mix kind of made sense. So that's like one part of the news, this acquisition, which will be interesting to see how it sort of develops. But they also announced a new product, Uno Q. Q as in Qualcomm, yes. I guess, and Uno as in the good old original historical form factor of those like fancy credit card sized boards with like always the same headers for all the shields and so on. And so what's different with this one is that I think when was it that the Uno R4 was released? Maybe a couple years ago.
A couple of years ago.
Yeah, so we already had Uno-shaped boards that had Wi-Fi on it, but one thing that's new with the Uno Q is that it goes even beyond that, is that there's actually, they call it the dual brain architecture. There's actually an MPU, Qualcomm-based microprocessor, and an MCU, an STM32 U5 MCU. So that's quite interesting, because that means that you can sort of like think and design your application around sort of like a scenario where you have the MCU looking at the sensor interaction and the low-level, potentially real-time safety critical stuff, and the Linux doing everything else, like connectivity to the cloud, potentially like running some beefier AI models and stuff like that. So yeah, that's the sort of the architecture, and the microprocessor they picked, the Qualcomm, how's it called again? We probably have that somewhere in the notes. Whatever, it's a Dragon Wing thing. It's effectively what you would have found in a mid-range smartphone from a couple years back, 2 years, 3 years back. So it's reasonably, it's good, right? It's low power.
In terms of capacity, but it's, I was trying to frame that processor last night, trying to figure what they mounted there. And it is not a phone microcontroller, because that's something that landed in many maker devices. It seems to be designed for automation type of application, and specifically the impression I had was that it's meant for machine vision. And so it's a quad-core A53, 55, something like that.
Quad-core, that name for sure, yes.
But the key feature is that it has 2 camera input, 1 display output, and then all of the fancy stuff for the whole AI image processing kind of deal. So the idea will be that you don't really need that much general purpose computational power, but if you use the accelerator, it should be fairly low power. This is something that they mentioned during the presentation.
Yeah, that's true. But in terms of sort of general computing compute processing power. Effectively, like the way they market it is that there is actually, so it's like you plug it, you have your USB-C connector, and you power it, and like it starts running. But if you effectively use the USB connector to also connect a display output and the monitor and the keyboard and the mouse, etc., it's effectively just like a Raspberry Pi. It's like a single board computer with which you can use as a desktop. Like if you connect a monitor to it, it starts. Yeah, you have a good old desktop. It's not the fastest and the smoothest experience. It's slowish. Knowing that the first version of the board that they've made available and the one I've had, I got it lucky enough to put my hands on, is only 2 gigabytes of RAM, which means that it's sort of like, choking, I guess, on all things desktop and so on. I'm pretty sure when they have the 4 gigabyte version, it's going to be much faster, but it's usable. Like, and you can definitely use it as especially for demos. It's quite nice to be able to just hook up a screen or even a touch screen, and you can interact with one of the things you can actually interact with is what they call the App Lab as part of the the way to write applications for that thing is that on the MCU, this would be typical Arduino sketches, and we can probably talk more about what's changed there. And on the microprocessor side of things, typically this would be Python with like what they've been making available in the so-called App Lab is what they call bricks, libraries, I guess, where you can really easily reuse nicely packaged components for building a web UI, for example, or for feeding data into AI models. This is made available as like really nicely wrapped, again, libraries. And there's also a so-called bridge that makes it really seamless to do RPC between the MCU and the microprocessor. So if your Arduino sketch running on the microcontroller has data it wants to make available to the Linux side of things, it can just push it into the bridge, or the other way around. From the Linux, you can pull data from the Arduino sketch that's running and feed the data into your Python bricks. So you feed the data into UI widgets, or you feed the data into AI models, etc., etc.
So this was really a triple announcement, right? So the first thing was the acquisition from Qualcomm. Then there was the new board, and then the software that you just mentioned that runs on the application processor. And I think it wasn't super clear, but I think the idea was that you can connect a monitor, and if you have one of those monitors with the USB bridge, with the keyboard and mouse, you plug the board and you get the IDE running on the Qualcomm CPU, and then you can run the IDE, and from there you flash the microcontroller and you can get the data back. So you can have a complete development environment without anything else really, and you can go mad with what you do with the STM32, because if you look at the hardware, the STM32 has the SWT lines connected to the application processor, so you can do source level debugging as well. And it seems like an interesting concept, and doing that is actually not easy. So the schematics of the board are already out, which is really cool of them because the board is on preview. And if you look at how the whole USB-C works for delivering video and USB data and everything else, it's quite some electronics. There's quite something involved. So it's worth having a look just for that. And I thought I would mention it because like Raspberry Pi doesn't do that, right? And people ask to have a Raspberry Pi that does all the multifunction on the USB-C port. They don't realize that there is a lot behind that, both in terms of extra hardware and extra firmware. And this board has one of the chip to do it, an ANX 7625, and they did the job. It works. It's really cool. So have you tried the App Lab stuff? How was the experience?
Yeah, so App Lab is actually quite nice. Maybe for like advanced or skilled developers, they will quickly move away from it. But it's a quite nice experience. Like and you just described, like if you use the board as a single board computer and hook up a display, etc., then you can like run that AppLab IDE on the board itself, or you can just download the desktop version and run it from there. It's just like a nicely packaged experience where you have a bunch of existing code samples, or you create your new code where you have sort of a framework to be like, hey, here's where you're going to put your Python code, here's where you're going to put your Arduino code, and then it has a nice way to deploy and test the applications, of course, to even make them and set, like whenever you're like actually happy with your application, say in my case, a demo, like my sort of official demo, you can make that the default application, which then becomes something that the board will run automatically when it starts, right? And so it will be like, whenever you reboot the board, it will always be running the same sketch on the microcontroller and the same Python script on the Python side. So that's and effectively it's just a bunch of Python scripts, an Arduino sketch. The Arduino sketch, if you want to do it or like build it and code it from the good old original Arduino IDE, that just works too. Like you can have in the Arduino IDE, you just download and install the Arduino Uno Q core, and you can then build and run from there. It works just the same. Because like, and you sort of briefly hinted at that, like the way the Arduino, the MCU core is being exposed to the microprocessor, but it's also exposed potentially to your main desktop computer, like using ADB. Effectively, my desktop computer can talk to the MCU through the board, potentially through the network as well. So it's pretty seamless. Like in a nutshell, I guess what I'm saying is that you use the Arduino AppLab if you want, or you use the Arduino IDE, or you use command line, or you, for the pure MCU bits, or you use pure Zephyr. Like that's also an option, because like it's right as we record this, the pull request is already out to have Zephyr upstream support for the Arduino Uno Q, STM32 side of it, at least, like that one brain out of the two. So it's the PR is out. You can effectively build Hello World, Blinky, whatever for the board and deploy it and run it sort of like natively right on the board, or you leverage the Arduino core, which is something else, which we can certainly talk about too.
Right. So how does it work if you use the Arduino core? I presume that they're using the LLX stuff, because they were very involved in developing the whole story. So do you know how it works?
Yeah. And so I did a demo on stage. I think we can put the link in the show notes. But yeah, it was like 1 minute and 20 seconds of like a really fast-paced demo. But one of the things the demo was meant to show, and hopefully shows, is the Arduino core in action. But I'm recording a slightly longer version of the sort of like the unboxing and the end-to-end demo that will show that. So the idea is that what they call the Arduino core is effectively what, for the past 20 years, people have been using when you build Arduino sketches and you do the fancy and really nice actually setup and loop thingy where you really don't think all that much about initializing your I2C and like setting up pins, etc. You only do pin mode, D7 out. You only do wire.begin to say that you want to start doing I2C stuff, like all those fancy high level Arduino APIs. They sit on top of, you need a core. So historically, they've been, as far as I know, most of the cores were built on top of Mbed OS, and then Arduino started to migrate to Zephyr, and so effectively, right, the bulk of the firmware that powers an Arduino sketch is effectively based on Zephyr. And when you start using the high-level APIs like the setup, loop, wire in it and digital write and digital read and whatever, those high-level APIs. This is effectively the Zephyr-based Arduino core. It was a Google Summer of Code, actually, that kicked off the work. And so when you use App Lab or whatever to build an app for Arduino, the Arduino core, effectively, you only compile an LLX module that's going to be deployed on top of the existing Arduino core. Historically, I'm trying to make that short, but I'm realizing that I'm not maybe super concise. But historically, building Blinky for Arduino on, say, the good old Arduino Uno, you rebuild the whole thing every time. Like you rebuild the core, you build Blinky. Whereas now, with the Zephyr-based core, when you build something like Blinky, you only build your actual like the actual code of the sketch, and it's going to be deployed on top of the core. So the core is a firmware that's already flashed on the board, Zephyr-based firmware, and the only thing it does is that it's expecting to find somewhere in a flash partition a binary that it's going to load and execute. And so that binary is effectively the only thing you build when you build your sketch. When you flash, the only thing you flash is this particular like really small, a couple kilobytes binary that's being put in this particular LLX loader partition thing. And then the board reboots, the core boots up, initializes all the peripherals, etc., and then sort of jumps to and starts executing the main entry point of the extension, which is of the sketch, which is going to go through the setup and the loop. But yeah, that makes for like faster compilation times, and that makes for also like, I mean, you don't rebuild the core because why would you? Like it's always going to be the same. So that was long, right?
No. It was good. I mean, this is something that is very important for them, and I think that it could probably be used for binding in other languages as well, if it makes sense. I don't know if it could be a thing for like MicroPython or Rust support, because I know other Rust-based OS that had a similar architecture. Yeah. It's just nice to see them using it and deploying it, because they like the Arduino are the guys of Arduino are the one that did a lot of development on this, and the Arduino folks, like I know some of them, they are really good for how small of a team it is. Like those guys are really good at handling this kind of acrobatics between like linker and we putting together weird things and making them work. That like these guys are good.
Yeah, and what I think actually was really fun for me as part of the demo is that like usually when we talk about Zephyr as an OS, for some people it might be confusing because they're like, yeah, okay, it's kind of okay, you call it an OS, but then when people build a firmware, it's effectively very monolithic. Like there's no, you don't have like processes that you launch and stuff, and it's like
right.
You build a firmware and it's like baked in, set in stone. Whereas here with this approach of using the linkable, loadable extensions like the Lex stuff and loading the sketch at runtime, it actually gets much closer to the OS experience, where you have this OS that's there, the core, and then it starts running apps. And that's actually what I've shown in the demo, is that you can effectively deploy multiple apps running in parallel. And so that's quite nice. Like to have you keep the pretty small footprint, and like it's like as minimal as it gets, but using Lex, you can be like, hey, you know what? After all, I don't have to run only one sketch. That setup and loop thing that works quite well for historically just running one sketch. Actually, if you start containerizing all the sketches in their own thread and with their own loader, etc., you can effectively run a Blinky sketch alongside another sketch that looks and interacts with some sensors, another sketch that maybe does whatever. I mean, and that gets much closer to the good old operating system experience. You have kind of a file system where you put all your binaries and you load them and unload them potentially.
Run them one at a time.
Yeah.
Tell me more about your demo.
Yeah, so I was trying to showcase some of that basically. So because it could have been like, okay, let's run Blinky and hey folks, this is Zephyr under the hood. This is cool, huh? Except that it wasn't maybe that exciting. So what I've been showing is that out of the box, for most people, it probably doesn't change much. But if people want to start using some of the Zephyr APIs and leveraging them in their sketches, they can. And in the past, I think some people probably did that too, when either like deploying free RTOS alongside their Arduino core and stuff like that. Effectively, like maybe 20 years ago, it worked really well to have this setup and loop sort of approach where you have this super loop where you process your sensor data and maybe you wait 100 milliseconds and then you read sensor data again. But when you want to do many things in parallel, it's not being tricky. You need a scheduler. And I think there's probably a few like really simple schedulers available out there for Arduino, or you just use Zephyr, basically. That's what it could add. So rather than doing your sometimes quite complex super loop, you just start kicking off new Zephyr threads with whatever priority you want and whatever, like you tweak them however you want, you synchronize them however you want with semaphores and whatnot. And that's one thing that I show in the demo, is that I can have like a really super critical, really important process and thread that interacts with one of my distance sensors, but all the at the very same time having another thread that's maybe slightly less important, but that interacts with my temperature and humidity sensor. Or maybe I add another thread which is diving even deeper into some of the Zephyr APIs to expose some metrics in terms of like CPU cycles being spent in all threads and like leveraging the thread monitor in Zephyr. And so, effectively, I think my demo has like, 6-7 threads running in parallel on the MCU. And then just tapping into the stuff that's already there in the Arduino App Lab and like the new experience they've unveiled, tap into the bridge to make all those things that I do on the sketch available to the Python side of things, the Linux side of things, where this is all being shown basically and exposed and accessible through a GUI, which, by the way, I'm going to name drop an interesting piece of technology I had no idea existed until I've used it through the App Lab and the brick they've made available. It's called Streamlit. You've heard about Streamlit before?
No, so never heard of.
So really, really cool. It's a Python lib. And they actually, even like on their website, they have a really nice playground and sandbox for it. It makes it really easy to have graphical like widgets for displaying metrics and to build effectively a web UI in Python. That's one, really good looking, and two, which you can feed data, whatever data you have in your Python script, you can like push the data to your widgets and the web page refreshes whenever it needs to. And so, for me, it was really convenient. So, because whenever through the bridge, I get notifications that the MCU has new data it wants to make available to me, then that data is immediately reflected and shown in the UI. So that makes for like, the Python side of my demo is, I don't know, like maybe a couple 100 lines of code tops, and it does a lot.
Right.
Like, it's very cool.
Yeah. So I wanted to ask you about the demo. So the demo was like two sensors and the LED strip connected with the quick bus, right? And then you were reading data and you were displaying them. One thing that was not clear from your 30-second demo was where the UI was running, and was the UI displayed from the Qualcomm processor on a display, or was it a web UI? Was it rendered from your laptop and the web server was on the application processor on the other side?
The latter. The Streamlit thingy, the Python thingy.
When you web UI.
Correct. Yes. So when you run that Python script, it effectively starts exposing a web server, which you can then like browse from wherever. I could have opened a local
it on the
browser.
Device.
Yes, but in my case, I guess I was just looking at it from my development laptop. But
right.
Yes.
Or you could have done a UI that was running locally, obviously. Right.
Yes, except that it's way more sort of like streamlined if you just use the the bridge. Typically, the bridge Python API thingy is really meant to be. You run the bridge like one side runs on the MPU, one side runs on the MCU. I don't think you can easily run the bridge on like something else, like on another.
Oh no! I was wondering if you were going to run the whole UI on the Qualcomm CPU and then just use the display output. That you can do it for sure, right? Like you could open a window. And we should mention they said that the Qualcomm CPU is going to use a plain Debian, so bog standard. That's cool, honestly. That's what I want.
Yeah, which is cool because and even for me, like when working with sort of like an early preview of the thing, you can apt get install whatever. It just works, and you're not sort of afraid that you will be breaking something. And it's quite nice. And you can, of course, like an SSH into the thing, and you can do whatever.
Right, and the board is. The connectivity aspect of that board is a bit weird, but I mean it's what it has for the type of application that CPU is designed for. But we should probably mention it. So it's a CPU, and then it has an eMMC, the RAM, obviously, the whole power supply thing, an eMMC on board. How big is it? Do you remember on top of your head?
16, I think.
16 gig. Probably.
Yeah, I'm not sure. Enough probably for that kind of. The RAM is more like the thing that might be limiting for some people.
So 2 gig is probably a bit tight if you want to run a UA desktop on it.
Yeah, but then one thing, and I mean, I have no. I don't want to make it sound like I'm really like aggressively sort of like promoting or pitching the thing, but like one thing that's really amazing, frankly, is the price tag, though. Like that 2 gigabyte version, and I think that's part of the reason they went for that. Yes, it might be limiting for folks, but it's like 39 euros / 44 US dollars, which is like.
Just try and look how much the STM32, because it's funny. Last week after we talked, I was looking at some STM32 for doing a keyboard with full speed connectivity for fun. I should propose it to the guys from the Tokyo office. Anyway, and completely randomly I landed pretty much on the same CPU, and it's like that one alone is very expensive, right? Like I'm looking for single quantity for myself, obviously, but it was like 13 euro alone. And with this one, you get the real time CPU, the STM32 CPU for real time stuff, the application processor, Flash as well, and Wi-Fi. Which does 2.4 and 5 gigahertz, and I would have loved to see some more connectivity, but that's just the initial offering that they're going to have, I guess. So I'm actually looking forward to see what they're going to do with future products, especially because Qualcomm does a lot of connectivity stuff. I think it's mainly wireless, but they probably have a lot of stuff on wired as well. And I don't know. I've been going through a bit of an Ethernet phase. I would love to see. Since it's kind of close to Raspberry Pi territory, it would be cool to see a device with wired Ethernet. Maybe PCI Express would be my dream. With the
and I think they have this connector at the bottom of the board that probably will be used for things like that. I don't know, or it's also compatible with the existing ecosystem of shields. I mean, for Ethernet, you might not get 1 gig. 1 gig Ethernet, but a good old Ethernet shield Like it just works out of the box?
Well, I mean, right now you would have to do like an SPI one, which would get connected to the STM32 side. So no, I think it wouldn't be really a good option in this case. Well, I mean, you could do it over USB. You could, I think that you could connect the USB in host mode and have an Ethernet USB, right? That would work fine.
Yeah, whatever USB peripheral. Yep.
Yeah, the connector. So the board on the top has the usual Uno type of format, and on the bottom there are, I think they call them like high-speed connectors or something like that. And I looked at the pinout, and it's mainly for the camera stuff. 2 camera input, 1 camera output. It looks like there is the parallel bus for the CPU in there, I think. So it may be possible to like stick an FPGA board and do some proper memory map devices. I'm not entirely sure, but they put some interesting thing. And another thing that I think stands out is that they have support for 24-volt power. So you can power it from USB power delivery, but then if you plug it on the bottom, you can go straight. Like if you have an industrial application, 24-volt is the standard. And I don't think it's very common to get board that can accept it directly. So like, very happy to see that. I think someone was thinking there.
Yeah, it's pretty cool. And by the way, but I think it's not necessarily new for some of the recent boards, but all the GPIOs on the like Uno connector, they are 3.3. They are 3.3 volts, not 5, as maybe was the case in the earlier Uno.
Yeah, boards. I wish they had dropped 5 volts long time ago, because I have an Uno R4, and every time I'm like, oh, this 5 volt, damn it. not a fan. But yeah, the CPU is 1.8. There are a bunch of level translator, and schematics are out, so worth taking a look. Good to see it. I saw some comment. I was looking at the live stream, waiting for you to go on stage, and there were some comment about, oh, it's good to see Arduino doing the Linux stuff. It's not the first time they do it. So the guys there have experience, and actually this remembered me. Back in 2013, I had to look it up. They were designing the Arduino the tree. And that was something that I absolutely wanted at the time, because this was when BeagleBone was the thing. And I absolutely love BeagleBone. And the Arduino tree was like a BeagleBone 8, an Arduino Uno, and got a bit bloated. You have to look at the picture. Like they literally have a 2-color seal screen, and the inner seal screen is the shape of the Uno, and then the BeagleBone is on the outside. Super cool. One fun thing I found like the announcement on Hackaday, and they mentioned like that there is an obvious comparison between the Tre and Raspberry Pi, and they're like, hardware-wise, the Tre is very close to the BeagleBone Black, which is a bit more powerful than Raspberry Pi. So this was 2013. Is not much the case anymore, because one of the things that got mentioned was like, this is the new Arduino one is at the same level of Raspberry Pi 3, but it's missing the point, right? Like the idea
completely, yes. Yeah.
This is not meant to be a general purpose CPU, obviously. While if you look at the Raspberry Pi, which got into the state that it is with the Pi 5 after many years, is by doing something that it's effectively a general purpose computer, and they're obviously backed by Broadcom, which I don't think that the CPU that they have is for them, because they do some version where they disable some part of it, but I think they have a voice, like a significant voice in the development. At least that's what I heard. But anyway, back to Arduino. So so the thread, the BeagleBone one never happened, which is a shame, because I loved the concept. But after that, they did a couple of revision of the Arduino Uno, which has been discontinued maybe 4 years ago. And that one actually, funny enough, ran an Atheros CPU, which is now Qualcomm, because they bought Atheros years ago. And it was the same concept, which I think is a winner concept, right? Application processor plus MCU, like real-time and non-real-time stuff. So this one was a CPU that was kind of an access point class type of device. And the MCU was an ATmega 32, which was the thing for Arduino at the time. And I think that is where they developed the bridge stuff originally. that is probably reused. So this is something that the Arduino guys know how to do, and they still have an AP plus MCU board as well. Actually, the Portenta X8, which is more meant for industrial application, and that one runs an IMX type of CPU.
Yeah, yeah. But I think maybe the main difference with what they have now with the Uno Q, and like you mentioned, it's effectively like upstream Debian, and like you actually have like a regular distro on that board, and you can like it's effectively fully sort of like exposed to people, as opposed to, I mean, the way I remember it in the Uno is that, yeah, sure, Linux was there, but you were not really meant to develop for that particular core, right?
Yeah. This is a different type of application.
Yeah.
So I think we should address the elephant in the room. What do we think about big 50,000 people corporation? I hope I got the number right. Acquiring a small Italian company doing a bit of a boutique product, because this was kind of the vocal comment in the various news outlets, like Reddit and some YouTube announcements I've seen. You go first, Benjamin.
Sure. Well, I mean, it's not surprising that some people would be worried. And of course, the Arduino community, just like many sort of like open hardware, open source communities, lots of people have like opinions on how this should be done, etc. But like, again, I guess like one reminder, like I think I started with that. Arduino, those are all like really nice boards and so on, and a really nice community. But there's always like, there's also a company behind it, right? And it's not like it's everything is free as in beer, and like there's people actually like doing business behind, etc. And on the Qualcomm acquisition specifically, again, I understand like big company, people being worried, but my impression from what I see from Qualcomm from the past like few months and what they did with the acquisition of Edge Impulse like 6 months ago and so on, is that they're on a path to like, they do some interesting, cool open source stuff and engagement, and being more also like more engaged and more visible in like Linux upstream work and so on. And some of the comments on YouTube, this kind of reminded me like 10 something years ago, when people were like, oh, Microsoft is evil and Microsoft is like trying to kill open source. Sure, yes, that might have been the case at some point, but then the company got sort of like through many rounds of transformations, and then things like GitHub and VS Code, I think more people now sort of agree that it's like, hey, you know what, this is actually really cool stuff. And part of it is thanks to whatever big corp is putting effort behind. So that's my take on it.
Yeah, I think it's justified to have some concern every time a giant corporation, I don't want to say eats up, because they became a subsidiary, right? And they were pretty explicit on saying like, yeah, things at least for now are gonna continue as they are. But yeah, so it's justified to have some concern. Now I don't have anything against Qualcomm really. I think it'll be okay, and specifically in this case. So the core product for Arduino is really like the how they call it. When you think of Arduino, you think of the 8-bit MCU board, like the traditional Uno, or like the smaller one. And Qualcomm does not really have a market in that. So I don't think anything is going to change. And to me, this is going to be a very solid lifeline for the Arduino guys to put resources in the IDE, which is really, I think the thing that takes more time from their developers is maintaining all of the software ecosystem. The hardware is hard, but how often do you do a new hardware platform, right? And the thing that what they really need is to be in the position where they can still doing new hardware every now and then, but they can also keep doing development on the IDE and do new fancy stuff with that, because that is the stuff that is going to evolve after you buy the product and you continue using it. But it's also the stuff that you're going to use if you have an non-Arduino board, which really hurts them, right? Like they have no economical incentive on supporting clones, and there's a lot of clones, because like Only people buy the original one. So I think it's good for them. And at the same time, the point where Qualcomm, I would expect them to have a voice, is the high-end product where they are going to put an extra Qualcomm CPU. And on that side, yeah, I would probably expect them to maybe focus on the Qualcomm one rather than, for example, the XP one that they have right now. Well, the previous one was on a Teros, so that would be fine. But I have no doubt that we're gonna see some cool high-end product, and they are gonna keep doing the basic makers kind of stuff, building blocks, as they are. And I think from an acquisition point of view, it's a good one. And it could have been a lot worse if some other companies would have bought them, right, without necessarily putting name. It seems like Qualcomm is a good one.
Right, and I think, yeah, go ahead.
No, I was going to ask you, like, let's wrap on this, and then I'll ask you something else about the event.
Right, yeah, I think just one last thing is that many of the comments were around the acquisition specifically, and like, yeah, okay, it's big corp acquiring this hobbyist / open hardware company. But one thing that will be interesting to see in just a few weeks is when people start getting their hands on the actual device, because I think it's going to go out people can order it right now, but it's going to be another couple of weeks until people can try it. But I think the early feedback from people is like looking at the specs and the price tag, etc. People are like, yeah, it's probably a really cool piece of device. And so when people start actually using the Uno Q, they might be like, yeah, okay, for now at least, like, let's keep doing some cool stuff with it because it's really good hardware, and let's see what the future has for us with regards to whatever Qualcomm does.
I think the future is bright.
Yep, I'm not worried personally.
Okay, Benjamin, did you ride James Bratton bike?
You call it a bike? I did not, but it was pretty awesome.
We should probably add some context. So they invited a couple of content creators to the event. Actually, one of them, which was not there, is one that I've been following for many years, which is Bob Claggett. I like to make stuff. And I think he didn't have time to do a proper presentation, unfortunately. But the other one that was there, which I don't quite follow, but it does some pretty cool stuff, is James Bratton. And the guy's been doing some massive builds. He did some Star Trek inspired things. But recently he did like a motorbike with Omni wheel, which is something that you used to see on RoboCap kind of robot, which again, nobody will know what I'm talking about, but they're interesting thing that allows you to move in both axes at the same time. And anyway, he had that demo, which I think was actually pretty much well targeted for the platform, where he was controlling the bike by moving his face, right? So he was properly doing machine vision with the Q. And I was wondering if you had a chance to ride it, but he said on the presentation that bike, in air quotes, has a 1 kilowatt motor, which is scary.
It's quad wheel. I wouldn't call it a bike. I think it's like it's a car almost. But it was there. It was on site, and it was pretty impressive. And I think he will be putting out the video maybe in another couple of weeks, like he mentioned. But it's really impressive. And using the USB camera, looking at like the face of whoever is driving, and depending on which direction your face is headed, it turns the wheels. It's really, really impressive. And you, as a 3D printer enthusiast, you would have been even more impressed, because the whole thing is 3D printed, like really huge blocks with like 2 millimeter like extruders, like so.
Yeah,
it almost feels like it's the raw filament that's being used to print the thing. It's like huge, like traces of like plastic. Like, wow, that was really cool.
Yeah. I have an A1 Mini, Benjamin. My printer does not do that kind of stuff. I know he has all of the type of device you need to do those type of projects. It's pretty mad. But yeah, we're having a look. I think it was cool for Arduino to actually acknowledge what people are doing, and give some more visibility to, not that he needs any, to this kind of creator that they do really cool stuff, and they use Arduino all the time. The other one I mentioned, Plugit actually has a Arduino for Makers course. So yeah, obviously it's kind of a situation where everybody benefits from this kind of content.
All
cool.
Right. Done with the Arduino stuff. Possibly by now, hopefully we haven't lost all our audience, but that was a cool piece of news. So let's talk maybe about some of the, and I was gone for most of the week, or at least like offline, as in I was preparing for this event, but you've probably seen some interesting pull requests and so on, as always.
This was surprisingly busy. Well, the first one I was going to mention was, now that we're done with Arduino stuff, let's talk about the two new Arduino Shield that you upstreamed for your demo.
Because there's I think they launched that reasonably recently, but they have a product line called the Modulino, which is a bunch of like similar to the seed, grove or groove sensors, or like quick, you mentioned, like I think SmartFan has a bunch. Yeah. So really simple standard connector for pretty much simple sensors as well, but you have like a bunch of accelerometers, distance sensors, temperature, etc. So we already had a few, which I think you actually introduced.
Yeah, I did the button and the LED strip, which you used in your demo. You're welcome.
Yes. Well, by the way, I wanted to ask you, and I will ask you on air. I think did you mess up the naming for the LED stuff? I think you called it Modulino Smart LEDs, but it's supposed to be called Modulino Pixels. So I think we need to rename that one.
I might or might not have had a pre-release of that module.
That's what I thought.
They might have I might have gone wrong, because I know.
Yeah, I think so.
There's some stories with those.
So, folks, if you've been using that one, we might rename it, I guess, because it's I guess it's called the Pixels. But yeah, it's pretty insignificant in a sense, because whatever those two new shields available, it's just for making it convenient for people interested in using those sensors. There's one that we still need to add, I guess. They have a knob, which would be nice to add. And I think it comes with its own MCU, so it has like a custom I2C protocol. So that would be a fun. People listening, that would be a fun PR for you folks to work on, because it's probably just like a few lines of like new input driver code. You might learn a few interesting things in the process.
Those boards are fun. Actually, I think I picked the name from the. Yeah, you're right. Those board runs STM32C0, which I really like, which is configured as an I2C target. And I think that they picked the Smart LED name from the code of that firmware, because I used that as a reference, and it was probably not the name that I used in the final product. But yeah, cool boards. Nice to use them. I actually really like the format. Cool.
Yeah, and they have. I mean, like I could show it on camera to you, which and I will.
Great podcast.
They also have like a nice thing to hold the sensors on some kind of prototyping board with the actual board that you can also attach to it. That's quite nice. Like that makes for a demo that you can carry around without breaking things and having to unplug. And so yeah, cool stuff.
Cool. Sorry about the name. Yeah, please rename it for me.
Yeah.
Jeez. New stuff. This is cool. There's more. It looks like we have more musicians working on the project, which I really like. So this is what's the name?
Yeah, Titouan made some iteration on the MIDI stuff. Historically, or like originally, this was USB MIDI, and now it's also
network UDP, MIDI over UDP.
Right, that's cool.
This is really cool. Do you know what is he using it with? Because I didn't know that you could buy like keyboard with Ethernet.
I don't know either. We should maybe we should do another sort of tech talk or something. But effectively new transport for MIDI. I think actually on Discord I also saw that our friend Eve was also playing with MIDI recently, and I think actually this particular PR So sort of like repurposed an existing MIDI keyboard she had and did something cool with an STM board or something. I can I'll put a link to the
I want to
discussion
see a
thread.
demo. Yeah, that is cool. Yeah, so the comment from him was, to best of my knowledge, this would make Zephyr the first OS with mainline support for MIDI for network MIDI 2.0, which I don't know if it means that nobody else is using it. It doesn't bring it much, but
or at least really I'm sure T2 is being pretty like. Usually, when someone says "to the best of my knowledge," well, usually it's true.
Did some research.
So I'm guessing it's like really, it's probably a really, it's a big deal. It's cool.
And the pull request comes with support for the Olimex MIDI shield. So I guess that so this actually gives you the old school DIN connector. So I guess you can plug a DIN MIDI keyboard and then put it on the network.
Yeah, does that mean that I have another MIDI demo in the 4.3 release video? Maybe. I'm not a musician.
I'm afraid you are now.
Yeah, I think so. And by the way, I don't think we mentioned it this week. We might have last week. Folks, careful. We are literally just, is this a week away now? Yeah, we are just a week away from feature freeze. So get your features in.
Yep. And talking about features, we had 2 new subsystems. So one is the instrumentation subsystem from the folks at Linaro, which apparently is for adding like profiling type of traces to the code. And this is actually meant to be used on the device. If I understand correctly, it saves the data in RAM. So we're going to lose some RAM from the device, and then you can download it and upload and visualize the data. You have to convert it using a Python script. The documentation is in the sample, awkwardly enough. I suspect somebody's going to get a request for moving the documentation in documentation. And you can upload it on perfetto.dev, which apparently is a thing.
It is? You've never used it?
No.
I think it's from Google, actually.
It is, yeah.
And it might have been called differently. I think originally this comes from... this was something that people would use as part of Chrome in the what's called like the web tools thingy, Control-Shift-I thing, whatever. Yeah. Those nice debugging tools that one uses to access the web console and whatever. And they made it a standalone tool, which effectively eats whatever traces that you get from anything really. And I've been using it for profiling and looking at performance metrics, etc. from Python, for example. Like you have you want to instrument a Python script to see bottlenecks and so on. Just a few lines of code. I usually need to Google them to remember what those are. But you run your script, you end up with I think it's JSON, some kind of JSON file, or maybe a binary, whatever, a trace file that you then go to perfetto.dev. Perfetto.dev. Perfect.
Yeah, exactly.
you load it and you start like digging into all the you see all your threads or tasks or whatever. Like in Python, you might not have threads, but you have you see the call traces and so on. One thing that I've been using it for as well, and works really, really well, is you want to troubleshoot performance issues with your build system and like with CMake stuff. Same, just a few lines of like a couple flags that you need to turn on, and once you're done running your CMake scripts, it will dump some kind of JSON trace, which you can also load and look at. And now I guess with what
of the build itself.
Yeah. Yes.
Brilliant.
And then now it's and there's a sample in this new instrumentation subsystem. Now it's also like for runtime stuff. You have a bunch of Zephyr threads, etc., and you want to see how they. And I mean, I knew this was coming. I need to look at it more closely because again, this will be like that'll make for a really cool demo for the new release. Yeah. It's really, really cool stuff.
Yeah, you have some demo work to do.
Yep.
Yeah, and the last one. This is the NVMem, non-volatile memory subsystem from Peter the Gent. This is interesting. So this is for accessing. This is meant to be used for accessing stuff like MAC address or other like temperature calibration stuff that you need, that data that you need to store on the device. And it's an interesting implementation. Right now, it's something that you define as a child node of a EEPROM, and then it automagically figure out that it has to use the EEPROM API using the iterable section for the device data, which is something that you should probably do a tech talk, because the way it's been implemented is brilliant, absolutely fascinating. But yeah, so this is meant to be used for storing a bit of information in the EEPROM, and it allows you to configure where the data is stored in the EEPROM from the device tree, so that your application does not have to hardcode memory offset and length to retrieve it. So yeah, simple thing, very useful. We actually have something like similar downstream, wondering if we could switch to this one instead. I like how better designed this is. It's interesting.
It's really, I mean, there's really lots of stuff that are going into this release, it would seem. So that's really nice. Cool. I think that's it for this week's news. Long part about the Arduino stuff, but I think and I hope you liked it, folks. Hopefully, no big acquisition for next week. And next week episode might be kind of back to normal. We will see what's new between now and then. Well, I'm sure feature free is coming up. I'm sure we will see a few other like big things being merged.
The podcast channel is live.
That's a really good point. We did finally create the hashtag podcast channel on Discord. Check it out to continue the discussion. That's something that happened last week after the episode. So let's keep that going. Like and subscribe. Bye.
Goodbye.